Okay, hello everyone. Okay, in this video we will see how to plot the Euler curve to represent the fatigue behaviors for each material. As we know, I have a simple definition of the fatigue. The fatigue is weakening of the material caused by cyclic loading. The condition that is not a constant, but it depends time. So it is cyclic loading. It results by progressive and localized structure damage and growth of the crack. And the fatigue, we have three steps for the creation of the crack or the damage of the structure or structure. The first step is initiation of the crack. The initiation of the crack is grow a small amount of each loading cycle, typically producing striation of the some part of the fracture surfaces. Normally, for this step, the number of the cycle is between 10,000 number of the cycle up to 1 millionth number of the cycle. Okay, to represent the first step, we can use normally we have three models. We have the Basquin model, we have the Stromayer, and we have the Basquin model. Let's start with this model, the Basquin model, to represent the oligocyclic. So the oligocyclic, so here we can oligocyclic is the first stud equal to is the initiation of the crack, as I see, is less than 10,000. Okay, number of cycle. Okay, so we can use this to plot the curve. We can use this model. The second part is the growth of the crack. Okay, is the most of the fatigue life is generally consumed in the crack growth phase. Here the rate of the growth is driven by other factor. So we have the effect of the main stresses, environment overload, and the underload can be affect the rate of the growth. Okay, is the material is defect for small as 10 micrometer. So mathematically we can use okay, we can use the Basquin model, because is the Basquin model is the crack, the growth of the crack up to the crack, the total crack, to the total damage of the structure. So here I can see we can use oligocyclic, as you see. So is the Basquin first step, Basquin model. Okay, we have the polygocyclic. Donc c'est the polygocyclic English is polygocyclic equal to the second and third step. Okay, is the growth of the crack. Normally we have is between 10.4 up to here we can see okay, is between 10, 1, 2, 3, 4 number of cycles to 1 millionth is 1, 2, 3, 4, 5, number of the cycle of the cycle. Cycle. We can use the Basquin model. Can use the Basquin model. Okay. So we have three steps. We have oligocyclic, the first start of initiation of the crack, and polygocyclic to represent the second and third the step. Here I have we can I use okay, very easy. Normally to represent the fatigue failure of your material, you can I use normally is strain life to represent the stress concentration is total life, total strain. Okay, it's very practical to use this equation. Normally we have the Basquin equation, okay, to represent the alternate stress in function to delta epsilon elastic, and we have okay, you can use it of to get the life, the failure in height cycle fatigue, and we can use the coffin and the Manson to represent the plastic strain amplitude is to use normally in the low cycle fatigue. So I can do one thing. We can okay, I use this screen, can help me for the programming. Okay, okay. Okay, now let's start to use to plot the graph to represent. Here we have the log failure number of cycle, and here we have the log of the strain. If we use Euler curve, normally it should be the other thing. Okay, don't know if yes, here we have the stress in y axis and the number of cycle in x axis. But okay, can I use this one or I use this thing? Okay, if we need the strain, can I use this graph? Okay, the equation can be combined onto the height cycle and low cycle fatigue. We can use this equation for the NF. Okay, we can use any values for the NF. So let's start with Python. Normally you should install the Python 3.7 with Numpy, also with Numpy library, and okay, we will use Numpy and Matplotlib to plot the curve. Okay, let's new file. Okay, we'll save as. We can use simple code here. Can save it as the fatigue curve. Okay, it's very simple. Now let's start with two comments. It should be defined in the first step. Is import numpy as in p. Okay, you can use also the matplotlib as mt to represent the any function like sinus, cosinus, tangent, and as in p. The first command is import matplotlib plot as plt. Okay, normally we need the B and C as input and E elastic modulus. Here we can okay, first comment is input. We have E gala is float input and elastic modulus given in EPE okay, EPE okay. The second one is B float input okay, don't know the names of these values. We have sigma f before we have sigma f or okay, the fatigue stress or sigma f is better. Sigma f okay, sigma f float input okay, the name is sigma f is the fatigue strength or fatigue strength constant of material, and the unit is MP. You should identify the unit. After we have B is two constant also depend to your material. Okay, is float input give input the B constant is without unit, so okay, and the same for the C. I have here one comments that C between minus 0.5 and minus 0.7 if in this range. Okay, after we need to create, okay, I don't know, yes, we have other constants. Okay, other constant is elastic F or elastic F okay, elastic F elastic F equal where the instruction is float input and fatigue okay is deformation constant of your material without unit. Okay, without unit. After we need to okay, to put this equation we have in x-axis is nf is number of failure, and delta sigma is in y-axis. Here is function. Okay, the first one I need to put the first and the last values. I can see one example here. Okay, an example is the material aluminium, brittle aluminium. The first values is 1 and the last values is 10 millions. normally, as I explained we have two-stud, we have oligocyclic, we have polygocyclic, and we have the growth and infinite endurance stud. Okay, the first value is 1, and the last value is 10 million life cycles. So to draw all the curve, so let's don't know. Okay, go back to uh, here we have n1 equal to 1 and n2 equal to 10 million. 1 2 3 4 5 6 7, and the increments is can I use example here equal 10, and after we define the function. Okay, define the function. The x-axis is n. I use the command np.arrange. We define the first value, the last values, and increments. It's very easy. And to define the function, here, as you see, is delta sigma divided by 2. But yes, okay, we can use the all values. Okay, can I use the sigma is delta sigma divided by 2 is all represent the sigma. Okay, not sigma, sorry, is the epsilon. Okay, can I use the function in y axis is epsilon equal to all these quotient is okay, is sigma f defined by a user, sigma f, sigma, attention, this comment is sigma f divided by e, okay, elastic modulus. Here we have the power function. Okay, should I use power 2? Okay, nf is sigma f. Attention, here is epsilon, is our variable. Okay, no, sorry, is n to n, and here we have b plus sigma f, elastic f, okay, power we have 2 n, and here we have c. Okay, and after we have PLT one plot. In the axis we have okay, the axis we have the okay, you have n, and the y axis we have epsilon. Okay, and to show the curve I use the command pt show. Okay, we'll run it. We start simple commands. We have elastic modulus is okay, 1 2 3 4 5. Okay, the fatigue strength suppose is 300, for example. Constant, okay, is 1. I don't know the values, but here okay, have put, okay, sorry, here we have the c constant, not the b. Let's start. Okay, okay, elastic modulus the elastic modulus. Okay, I have here some example for the fatigue calculation. Okay, can I use this material? Depend to your data. Example, we have can I use this one 108 CE. The E is 2007. Okay, 1, 2, 3. The strength fatigue is sigma F. Can I use these values? 956. The B constant B. Normally we have C and we have N. I don't know, but there are some relationship between B and C and N. Okay. Can I use these values, for example? It depends on your material, but just try to have the plotting of the curve. The C, okay, the C is exponent. Okay, as I see in the code is between -0.5 or 5 and -0.7. Can I use, for example, -0? Okay, 6. And the fatigue deformation constant is epsilon f. Okay, can I use 0.59? And we have the plotting of the curve. Here I have some remark. Is deformation and is the values as I plotted. Okay, we will go back to this curve. Okay, can I use the log to have the approximation? Okay, have the better representation of the curve. Can I use NF in axis x-axis and the deformation in y-axis? Okay, can I use this thing? Try to change. I don't know, but just I will change the B constant and I will see what can I go as a result. Can I get as a result? Okay, the elastic modulus is the same values. Okay, the strength, fatigue strength same. Okay, the constant, for example 0, 1, we'll change it. Okay, the C, keep it the same values, same value, and the fatigue the same 1. Okay, we'll get the same okay, observation. I don't know. We can I use the log. Okay, to I use the log, we just need to okay, to use the other variable like okay, like log n. I can use log n is in p log this then n. I use log or ln. Okay, it's not a problem. Okay, and epsilon with epsilon log. Can I use log epsilon is the other variable is log is in p 1 log n, and here we have epsilon. Okay. And automatically we change here log n. Okay, and here is log epsilon. And okay, I will put the same values here. Okay, 9 6 minus 0 1 minus 0 6 and 0. Log n is not defined. Sorry, is here. Put some log n, and I will run in again. Okay, I have the same value. Okay, 956 minus 0 1 minus 0 6 and here 0.59, and I will get the better representation. As you see here, if we use the log, we get the better representation of the curve. Can I use okay other thing like okay, like okay, you can, if you okay, you can okay. Now if we want to give the name for x-axis as log n and y-axis as log epsilon, just we need to add two other comment. Okay, let's go back to our code. We plt.xlabel and we give the name xlabel. The name is log n. Okay, and plt.ylabel and is log epsilon or log e or log epsilon, and to plt.show, and we will run in give the same values for e for fatigue strength 956, b minus 0 1 example here minus 0 6. The values depend your material. For each material we have elastic modulus, fatigue strength, b constant, c constant, and you have the fatigue deformation. Okay, and you will get the curve. We have here log epsilon and log n. Now if you want to add the title, okay, forget is plt. Title example is e epsilon e slash n method. Okay, and we'll run it again. Okay, save it first. Okay, we set the same values. Okay, 9 6 minus 0 1, c minus 0 6, and here 0 9. Okay, here we have the okay all the thing. We have log n, log epsilon, and is en method. As I see, we have normally two method to give the presentation of the fatigue analysis, like epsilon n, and we have model Euler curve to represent log n function to to represent the stress, and function to n or the number of cycle, and epsilon n and function to deformation. Okay, let's go back to Euler. So we need to have the okay description of for each model, as I explained before. Okay, we can I use this model. Okay, I need okay, okay, can I use this? The log is better. Okay, let's go back to the model. Okay, I will just okay, just save it. Okay, just save it, this one. Okay, or we can I use order to have the function. Okay, the result. I use the result. Okay, result. We can I use the, let's save it. Okay, as input I need the C and M. The very important is parameter defined normally to your material. Okay, to your material. We can use log. Okay, I need C values and okay, I need C. Okay, and I need the M. And okay, and y x-axis is n and y-axis is the stress. Okay, first one, I need C. Okay, I can add it here. Okay, this current C is different than this one. It is a constant depend to also to your material. Current C. Okay, and I need M. M is the okay, float input. Okay, can copy paste and change here the M constant. Okay, for the function we can example. Okay, just change something. Okay, like okay, I can start with okay, we can start with this thing. Function 1 here, function 1 here, we have function 2. The comment is function 2. Okay, I'm gonna past. You have the same thing here. You have the n, but put attention that because we need to have the log sigma a. Donc okay, you can get okay, okay, can have is the log n in x-axis, and we need to define log sigma a. Log directly is log sigma equal to okay, equal to log n, already defined, okay, by default by this command. Okay, is normally log c, not, let's start with log c minus log n. Okay, okay, here is log c log n divided by m. Okay, divided by m. But here okay, I need something. Okay, it's in p because it is mathematics. Okay, okay, okay. And I read in the results, I will just copy paste, and after we will change some parameter. Okay, like here is log n, and here we have log sigma. Okay, here is log n, here we have log sigma. Okay, here is n method. Okay, okay, now let's check. We start with first method is okay, 907. Okay, minus 0 1, minus 0 6, and 0 9. I don't know why I don't have the okay, the first curve. Okay, let's the C constant. The C constant is depend to as I see depend to your material. Log C is log n. Ym is depend to okay. Okay, let's have some values here. Okay, don't know. Okay, 600 or okay, 200 for example. The M is 5. Okay, I have the first one, but second curve don't give the log n log epsilon. Okay, let's check. Okay, I will remove the first function. Okay, and I will keep only the second. Okay, I will new files. Okay, we can copy all this thing and we'll keep it only the what I need. Okay, for function I will remove the result for first function. We will keep the second function. Okay, here in the parameter I need only the C and M. Okay, the C and M. Okay, C and M. So I need something here. Numpy. Okay, input. No, is your input. Okay, input the second function and okay, in the result I will save as here we have sigma n function, sigma n curve, and I will run in. Okay, give C constant 200 and the M constant on your material 0 5. Here I get representation of SN method. Okay, it's given as logarithmic okay, logarithmic scale. Okay, as you have the remark in this curve that we have is linear representation, linear curve. If I use the okay, let's see. Okay, normally it will be the linear curve. No, to have the okay, to have the real curve like n function to sigma. Okay, we'll go back to our script. Yes, here we will change to n. So okay, I use n. Okay, n is already defined. Okay, I have sigma. Will convert log to and see the relationship between sigma and log to sigma. Sigma is p point exp exponential y. Okay, log sigma. Okay, in p point ln is log 10. Okay, that is the okay, the command I use to convert the log sigma to sigma, and the result will change. Here is the n. Okay, and for the log we convert to sigma. Okay, you have the n and the sigma. We'll plot. Okay, rain. Okay, we'll put same thing here 0 5. Not okay. Have some things not okay. Let's change the values. We'll go back to our history. Okay, to our script. We'll run in and we'll change like have the m. It should be okay. The more than one. Okay, can do something. We have the constant. Okay, we can refer to same data, the material to get okay, yes, for example here okay, we'll have example of the metal material, metal alpha beta alloy steel. Okay, we have the values of m and b in our case is c, the same equation. Okay, but before we need to change here the n1 because as I see before the Basquin model is described just the last or the high cycle life starting by 10,000 cycle number of cycle, and the maximum is okay is okay 10 million. Okay, and okay, and I will run it again. The see we can take okay these values. Okay, 19 E22 and cm for example is okay for 5 here 0.6. Okay, and I will plot it and get the SN curve. Okay, here we have the maximum value is very huge than the standard. So I think there are some issues here. For okay, for the minimums, I don't know what is the issues. Can I use Oracle 9 to have the M? Can change C the effect for the C to our results. I will try with other example. I will run in. Okay, for the C can take 2 E20 and M. I get okay more or less okay. We'll check okay the program. There are some problem. Okay, have this correct. Log n is log 10n. Okay, we have log sigma is EP log c minus log n, and sigma gala NP point exponential log sigma. Okay, I will do some example. Okay, sigma NP. I will just remove this thing because it is okay. I will run it again and take the same values by default 1 9 9 22, and for the m we take the same values is 5.6. okay, we'll get more or less than previous values. Okay, you can we can check if the minimum values, for example here the low number of cycle is an average 36,704. Can take the same 36,704 and I will run it again. Okay, take the same values of for the C and M. 22 and here 5.6. okay, it's not a big difference. It's not a big difference, so I can take the okay. Okay, we'll go back. Okay, I will change the I think the C. It should be less than the first variable. Can I use, for example, 20, just 20, and here 6, 7. Okay, it's divided by 2, so okay, I will run it again. Is 1t6e. Okay, can I use just 17, 18 in here? 6.6. okay, I think is now is better, but the main important is to check your available values for your material, because for each material you need to have the C and M to plot this curve. Donc, so in this tutorial we check for both method SN and EN. Okay, thank you for your attention. Okay, if you have any question, you can contact me on my Gmail. Okay, and not forget to subscribe me on my YouTube channel, and see you again in next episode.